Now that we understand what contour lines are, we need to learn how to interpret them so we can understand the shape of land surfaces that are shown on a topographic map. Fortunately, contour lines follow some very simple rules. Once you understand those rules, being able to visualize the shape of a land surface on a topographic map becomes much easier. The first rule of contour lines has to do with their spacing when we look at them from above in plan view. Remember that contour lines are evenly spaced vertically and that they represent lines of equal elevation. However, when we look at contour lines in plan view, we can see that some lines are closer together horizontally and some are further apart. Where contour lines are closer together, they indicate that the slope surface is steeper. Where contour lines are further apart, the slope has a shallower angle. Here in Google Earth, we can rotate to a perspective view, and right away we can see that the area where the contour lines are spaced further apart represents a much flatter slope than where they are more closely spaced. We can see this difference in slope angle as we rotate to a profile view. Again, you can see that the contour lines have the same vertical spacing between each line when viewed in profile. But as we rotate back up to plan view, we can see that the contour lines are more widely spaced on the shallow slopes and more closely spaced on the steeper slopes when we are looking at them from above in plan view. We can use this relationship between vertical spacing and horizontal spacing to calculate the gradient of a slope, something we will do later in the upcoming lab assignment. The next rule of contour lines is that they do not ever end. A contour line may appear to end at the edge of a map, but it is always continued on the next map over. Around a small hill or the summit of a mountain, contour lines will form closed loops or rings, such as what you can see here. Anytime you encounter contour lines that form concentric rings, you know you are looking at a hilltop or some kind of a mountain peak. The last rule of contour lines has to do with the shape they make as they cut across valleys and ridges. In this view, we can see a small stream that runs downhill from higher elevations on the right to lower elevations on the left. Okay, let's take a look at this stream valley in a little bit more detail. We'll use the imagery in Google Earth and examine this valley from a perspective point of view. From this point of view, we can see the path that the stream takes as it drains off the side of Dome Mountain between the small hills on either side. Now, let's take a look at the contour lines on that topographic map and look at how they cross this stream valley. You can see from this profile view that the horizontal contour lines appear to cut directly across the valley. However, as we change to an oblique view, we can see that the contour lines wrap around into the valley, forming sort of a V shape. And as we transition back up to plan view, we can see this distinctive V shape formed by the contours as they cross the stream valley. One very useful rule of thumb when reading topographic maps is that if the point of a V-shaped contour line is pointed uphill toward higher elevations, then we know we are looking at a valley. A similar thing occurs when contour lines wrap around a narrow ridge on the side of a mountain. Here again we can see that the horizontal contour lines appear to cut straight across the ridge when we view them in profile. But as we transition back up to plan view, we can see that the lines wrap around the ridge, forming a gentle V or U shape. If the bottom of that U-shaped contour line is pointed in the downhill direction toward lower elevations, then we know that we must be looking at a ridge. Now that you've covered the basics of contour lines, have a look at Chapter 9 in your lab manual to read more about interpreting contour lines and the landforms they represent. You should pay particularly close attention to figures 9.10 and 9.11 in your lab manual, and make sure you look at them often while you are working on your lab assignment this week.